Okay. So here, these numbers in the front are similar to my coefficients over here, yes? Do we agree?
Yeah.
What are my, so technically out of here, what could I call my base? Out of scientific notation, what is my base going to be? What's that thing that has, what has the exponents attached to it? In both problems. And over here, scientific notation, what has the exponents attached to it?
10.
The 10. Alright? So our base for scientific notation can be considered. Zoom in a little bit. So if we're looking at this problem, the 3 and the 2, okay, are going to be our coefficients, and those is what we multiply. This right here, the times 10 to whatever, those are your bases in scientific notation, okay? Because all scientific notation is some number times 10 with an exponent, right? Do we agree with that statement? If it's in scientific notation, you know it's going to be some number times 10 with some sort of exponent. Okay? You with me so far? We all right? In doing so, we can treat this just like the problem on the board, where, and I'll write it on here as well. So the 4 and the 6 in the problem are similar to the 3 and the 2 in terms of scientific notation. They can both be considered coefficients, okay? Whereas the x is the base in our top problem, and the times 10 to whatever exponent is the base in scientific notation, okay? So the rules still apply. We're going to multiply our coefficients, and we're going to add our exponents. So notice that we have multiplied 3 times 2. Reed, please look at the board. Thank you. And then we have our base of 10, and we have added our exponents. Okay? Let's give it a whirl. So let's look at where it says you try for the number 1. Okay? So now, what am I going to multiply? What am I going to add? Go ahead, Lee. Very good. So I'm going to multiply the 4 and the 6, and I'm going to add what?
4 and 8.
Very good. So in doing this, I'm going to multiply 4 times 6, and we know our base is this, so we're automatically going to write, it's going to be times 10 to the what power? 4 plus 8 is?
3.
Yeah, go ahead.
12.
Very good. So we finish off, 4 times 6 is 24. Times 10 to the 12th. Okay? You can put this in your calculator. Okay? And you can put it in exactly the way you see it. And when you do, you will notice that you will get a slightly different answer. In your calculators, you need to be very careful that you must put in, calculator, you must put in parentheses 4 times 10, the little caret button, raised to the 4th power. As soon as you're done this, you must press that arrow button and hit close parentheses. Because if you don't hit the arrow button, then the parentheses is going to stay up here with the 4. Okay? It seems trivial about the arrow button, but you have to press the arrow button. So parentheses, parentheses, 4 times 10, caret button to the 4th. Hit the arrow button so you get the big cursor, close that parentheses, and then do it again. No, put that to the, no. Put the whole top problem in.
Oh.
Put the whole top problem in. What did you get?
2.4 times 10.
Right, so you got, let's talk about this. So as an answer, when you put in your calculator, you got 2.4 times 10 to the 13th. What do you see? I want to have this conversation about, and we didn't have it before because I wanted to have it now, and this is why I'm giving you calculators as well. Both of these answers, the 24 times 10 to the 12th and 2.4 times 10 to the 13th, I almost said 13th, that's terrible. They both represent the same number, okay? If I were to expand both of these, right, it's terrible. If I wanted to expand this to where, like, and give myself those 12 zeros, again, terrible, no one wants to do that, I would end up with the same number if I were to do it this way, okay? Is this in correct scientific, it's in scientific notation, do we agree? But is it in correct scientific notation? Yes or no? This is like my B answer. This is my A answer. Why is 2.4 my A answer, whereas 24 is my B answer? What do you know about scientific notation? What am I allowed to have? In terms of right here, what am I allowed to have when things are, what? Go ahead, give it a try. I'm talking in terms of decimal. So when we learn about scientific notation, what am I allowed to have? Am I allowed to have 2 digits in front of a decimal, or am I allowed to have 1? 1, okay? Here, in 24 times 10 to the 12th, my decimal is here, yes? Okay, so again, B answer. This is my A answer, because this is where it belongs. But notice, when I moved my decimal 1 place to the left, what happened to my exponent? It went up. So I moved left 1 place, right? And this went up by how many? 1. Okay. So again, not a wrong answer, but this is like your A answer, okay? I'm not expecting you to be able to. This is why we do calculators, all right? But notice that when I move my decimal 1 place to the left, this goes up by 1. If you were to expand these, you would get the same exact answer with a ton of zeros. Okay? Alright, so I want you to try that. I want you to do this. Do the next 2 in your calculators. I want you to put them in your calculators. I still want you to draw out what exactly you're doing. So I want you to show me what I like to call the over-under rainbow. So put that in your calculator. Draw my over-under rainbows. I want to at least know that you are aware of what you are multiplying versus what you are adding. Okay? Absolutely, because you did it by hand. We just had to move the decimal over, which is, like I said, not wrong. But notice again. All right, so we're talking about and that's why the hardest part is making sure is to put this in correct scientific notation. But if you have a calculator in front of you, I love the fact that if you can do this without a calculator, that is phenomenal. If you need a calculator, that's okay too. All right? But I want to teach you how to put this in a calculator because you can use a calculator on Olive Park. It's terrible. But, all right, so what am I multiplying? What am I adding? Read, what two numbers am I going to multiply?
4.5 and 6.7.
Beautiful. So I'm going to multiply those two numbers. And then I add what two numbers?
2 and 9.
2 and 9. Awesome. When I multiply, so without a calculator, when I multiply 4.5 times 6.7, Ashley, what did you get?
Oh. 30.15 times 10, 11 to the 11.
Okay. Someone who put it in a calculator, what did you get? If you put it in, go ahead.
I got 3.05. Wait,
Yeah, 1.5, yup.
yeah, times 10. And then it will go up
To the,
to the 13.
so it should be to the 12th because we went up. So now look, here was my decimal, right? In the one that we did by hand. The one that we did with a calculator, my decimal moved over how many places? One place to the left, right? Since my decimal moved one place to the left, my exponent gets to go up 1. Because think about it, and this is the way to think about it, maybe if you needed a visual. If I were to expand this, I would move this decimal how many places? 11, right? Now, I have to move, now for this one, the reason that this goes up is because now I have to move now, if I want to expand this, I need to move my decimal how many places? 12, because I just have an extra space, right? So if I go one place to the left, then I need to move this up 1, because if I were to expand it, that'd be one more step that I would have to take. Does that make sense? You all right? It's tricky. That's a tricky concept to visualize, especially when it's so hard to conceptualize how many zeros and what and what. All right, let's look at the next one. What am I multiplying versus what am I adding? Go ahead, Leigh.
We're multiplying 5 and 8.3.
Uh-huh.
And adding -2 and -5.
Very good. Okay, so 5 times 8.3 is what? What is it?
41.
Okay, so I get 41.5 times 10 to the, what is -2 plus a -7.
You just gave us the answer.
Shh. Whatever. It's been a rough morning, all right? All right. So you get a -7. Where do I want my decimal to be? Let's practice this. Go ahead.
Go over 1, it'll be between 41.
So I'm going to move this over 1, so I get 4.15 times 10. Now, so I went to the left 1, so that means I need to add 1. So this is the tricky part. So now I have to add 1. What's -7 plus 1? -6. Very good. This is the part when you're dealing with negatives and adding the exponents that people kind of go,
Well, this keeps telling me to update my password.
oh, because it's being saved for Moby Nights. It doesn't matter. Okay. These are your favorite. You love these. Now, we're missing pieces. So looking at number 1, I gave you the answer, right? I want you to give me a value of A, give me a value of B. If 24 is my final answer, what does A have to be? Because what do I have to do to these two numbers? Darn it. I have to multiply. And then these two numbers I have to do what? Add. So what is my A value going to be? 4 times what gives me 24? 6. Very good. 2 plus what gives me 7?
5.
Lovely. All right. Now, is this incorrect scientific notation?
No, it's like the B answer.
Right, that is my B answer. So what do I have to do to give me my A answer?
You have to move it over 1.
So I'm going to move my decimal is here. I'm going to move it over 1. Since I went left 1, I have to do what over here? I have to go up 1. Very good. So I'm going to add 1 to there. So my final answer looks like 2.4 times 10 to the 8th. Okay. Try again. I want you to try this on your own real quick. Why do you not have what I had written down? You are not following along, Regina.
Sorry? That's 7.
All right. What value am I getting for A? What value am I getting for B? Go ahead, Ash.
3
3 for A, okay.
and 1 for B.
And 1 for B. All right. Am I in correct scientific notation? Yes or no?
No.
No. All right. Fix it for me.
2.4 times 10 to the 8th.
Awesome.
Same one as the last one.
You are correct. All right. Your homework